Swayam Prabha. Digital India. Educated India.
Welcome back. So, in the last lecture we just discussed about several issues related to the consolidation, and there we have found out that we will be able to plot the variation of void ratio with respect to the effective pressure. That means, if you increase the effective pressure, that means basically you are increasing the total stress or the total pressure, and that ultimately that will increase or enhance the effective pressure. So, that will be same, the total stress increment will be equal to effective stress increment at the end of consolidation, of course. So, you can, so if you vary the effective pressure, you can get the variation in void ratio, and which can be plotted in some semi-log plot, right. So, that already we have discussed in the last lecture. So, now we will see in this lecture, we will see that how the plot will be looking like. So, along y axis you will be having void ratio E, that is the normal axis, and along x axis that is your log scale. So, along x axis you have the effective pressure. So, that means say E naught was your initial void ratio. Okay. So, now if you increase the total stress sigma 1, and which will be eventually will be becoming the effective pressure sigma 1 prime at the end of consolidation, at that time you will be getting some reduction in void ratio, that is say delta E 1, and so you will be getting the final void ratio as E 1, which is equal to E naught minus delta E 1, right. Already we have calculated in the last lecture. Similarly, if you increase the effective pressure, rather total pressure, and which will be eventually becoming the effective pressure. So, if you increase that, that is sigma 1 prime to sigma 2 prime, if you go, you will be getting further reduction in the void ratio, and you will be getting the void ratio as E 2. So, these are the things we have seen, and we have seen that how to calculate all these parameters, all these values, right. So, you will be getting, so if you join this thing, so you will be getting a nonlinear curve like this. Okay. Now, E log sigma prime plot is somewhat curved with a flat slope, followed by a linear relationship for E with log sigma prime having a steeper slope. Okay. So, I mean this is a common trend or the common say scenario observed in the consolidation plot. So, initially it will be curved with a flatter slope, and then you will be having some linear relationship with steeper slope. A soil in the field at same depth has been subjected to a certain maximum effective past pressure in its geological history, right. So, please try to understand, it is very conceptual. A soil in the field at same depth has been subjected to a certain maximum effective past pressure in its geological history. Now, what does it mean? It means that suppose you have some soil deposit. Okay, if you go to some depth, okay, and if you consider some soil block or the soil element, that soil element will, I mean already has experienced some previous pressure or the pressure history or the stress history. Suppose for example, suppose I have some soil deposit, and on top of that long back maybe some glacier was there. Okay. Now, this glacier is not there, because the glacier has gone away and it has become water or whatever. So, glacier is not existing now. So, what will happen due to this glacier, the soil is already compressed, already consolidated under that pressure, whatever pressure was developed or generated by the glacier. Now, the glacier is not there, but soil will remember that stress history. Soil is having a very good memory, right. Soil will remember that stress history, that already I have experienced this much of stress due to the glacier. Now, the glacier is not there, that is different issue, but I can remember that much of stress. For that much of stress I am already compressed, or I am consolidated, right. So, this is nothing but very important phenomena, and this will tell you something about the soil, whether it is over consolidated or normally consolidated or pre consolidated, something like that. Okay. So, we will come to that point later. I hope that you have understood, right. The soil which has already experienced some stress in past, right, geological history. Okay. So, it has experienced that, and now that pressure or that load is not there, but still it will remember that history. So, this maximum effective past pressure may be equal to or less than the existing effective overburden pressure at the time of sampling, quite obvious, right. Due to that glacier, whatever example I put in front of you, due to that glacier, whatever stress was generated and whatever due to that the soil was compressed, now you are going to construct some building. If that building is, I mean, that building will create some extra stress or extra pressure, right, in the soil. Now, if that pressure is that pressure due to that building, newly constructed building, it may be or may not be greater than that the previous or the historical glacier pressure, am I right. So, glacier pressure, suppose the glacier has given me some sigma 1. Okay. So, now soil is compressed or has been compressed under this pressure. Now, the glacier is not there, but still soil can remember that I have been compressed under this pressure, okay, by the glacier. Now, you are constructing some building, okay, and or maybe some structure on top of the soil, and that structure is giving some pressure or creating some pressure sigma 2. Now, this sigma 2 may be greater than sigma 1 or sigma 2 may be less than sigma 1, right. So, if your sigma 2 is greater than sigma 1, that means you are crossing its previous history. That means, soil will tell, okay, you are crossing my limit, already I have experienced this much of pressure, but now you are increasing the pressure. So, I will compress. But if your sigma 2 is less than sigma 1, that means soil will say, oh, okay, I have already experienced this much of pressure earlier, now you are applying this much of pressure which is nothing for me. So, I will not come. So, this is the thing soil will remember. Okay. So, I hope that you have understood this thing. Okay. So, now when such soil is subjected to a consolidation test, a small amount of compression will occur when the effective pressure applied is less than the maximum effective overburden pressure, right. So, in the field to which the soil has been subjected in the past. So, please try to understand, when such soil, whatever soil we have discussed just now, that means it has got some previous history. Okay. When such soil is subjected to a consolidation test, a small amount of compression will occur, when the effective pressure applied is less than the maximum effective overburden pressure. That means, if this condition is valid, sigma 2 is less than sigma 1, if this condition is existing or is getting applied, then which the soil has been subjected in the past. That means, whatever load you are applying now due to construction of some new structure, that load or that that structure will give some pressure, and that pressure is less than the previous or the historical pressure whatever soil has already experienced. So, under that situation you will be getting very marginal or the small amount of deformation, right. Very marginal deformation, because soil will say already I have experienced this much of this is something like that. Say suppose you can carry 10 kg or suppose your capacity is 10 kg, right. So, now if I apply some 15 kg load on top of you, then you cannot take care of that. But if I give you say 8 kg or 5 kg, then you will say already my capacity is 10 kg. So, I can carry 5 kg or 8 kg, right. So, this is something like that. So, when the effective pressure on the soil become greater than the maximum effective past pressure, the change in the void ratio is much larger and the E log sigma prime relationship is practically linear with a steeper slope. So, this is happening during that time, okay, steeper slope, when you will be getting the steeper slope. When the effective pressure on the soil become greater than the maximum effective past pressure, that means, when your sigma 2 is greater than sigma 1, at that time you will be getting very steeper slope. Initially you will be getting very flatter slope, as I told you in the E log sigma prime plot. I told you that initially you will be getting very flatter slope. When you will be getting the flatter slope, at that time your sigma 2 was less than your sigma 1, that historical or the previous or the past pressure, right. Now you are increasing the pressure, and that basically sigma 2 is now becoming greater than sigma 1. So, that now soil will say no, this much of pressure I have not experienced, okay, now I have to compress, that is the phenomenon. Okay. So, at that time you will be getting very steep slope in the E log P, E log sigma prime plot. So, now you can see here. So, this is nothing but very typical E versus log sigma prime plot. So, so you have A, B, C part, and then you have F to D part, right, a C to D part, and then further D to F and G. So, you have A, B, C one part, okay, or then you have C, D part, and then you have D, F, G. So, there are 3 distinct parts. Okay. Now, we will see that what are these parts. C D represents unloading. So, if you look at the figure once again, C D, so that means you are loading it. If you move in this direction A to C, okay, you are loading it, that means you are increasing the load, right, and due to that you are getting some reduction in void ratio. Now, after reaching C, you are unloading it, that means you are reducing the load or you are reducing the effective stress. So, that means you are moving in this direction, right. So, that means you will be getting some enhancement or some increase in the void ratio. So, you are reaching D. Okay. Now, after reaching D, you are reloading it. So, D, F, G represents the reloading branches. So, D, F and G, this path will talk about the reloading. That means, say when you are at D, try to understand, when you are at D, if you apply load, so the soil was already compressed at some loading C. Okay. So, say sigma C prime, the soil was already compressed at sigma C prime. Now, some unloading happened in the along the path C D. Now, you are at point D. Now, you are reloading it, right. What you are doing? You are reloading it, that means you are applying the load again. What will happen? You are reloading, but you see you are getting some flatter slope. Why? Now, whatever stress you are getting, all these stresses, they are less than your past pressure sigma C prime, am I right? So, you will not be getting very steep slope, the flatter slope. Soil will say already this much I have experienced sigma C prime, what you are putting now? Now, whatever putting I can take care of that. So, now once you reach this point F, say for example F, it will not be exactly matching to point C, some gap will be there as shown as dotted. So, once you reach F, then soil will say no, this much of pressure I have not experienced, now I have to do something or I have to compress. So, now you will be getting very steep slope from F to G. Okay. So, this is happening actually. So, from D to F you will be getting some flatter slope because soil has already experienced this much of pressure. Now, from F to G you will be getting very steep slope because soil has not experienced this thing earlier. So, this leads to two basic definitions. First one is normally consolidated, whose present effective overburden pressure is the maximum pressure that the soil was subjected to in the past. So, when I say my soil is normally consolidated, that means whatever pressure I am applying, under that pressure soil, I mean that is the pressure what soil has experienced, I mean that is the maximum pressure rather the soil has experienced in the past also, right. So, if you look at this point, say when I am moving from F to G, do you think the soil has experienced the pressure greater than say sigma F or sigma G? No, never. right. The soil from F to G will be behaving as normally consolidated soil. That means, soil has not experienced this much of pressure never in its lifetime. Okay. So, that is normally consolidated. Now, the second one is over consolidated. Now, whose present effective overburden pressure is less than that which the soil experienced in the past. So, when you are moving from D to F, at that time the soil will be behaving as over consolidated. That means, soil has already experienced the pressure sigma C prime, but now whatever pressure you are applying, that is less than sigma C prime. So, soil will say, okay man, I am already experienced this much. So, do not expect anything very new from me. So, I know how to carry, right. So, this is at that time the soil will be known as over consolidated soil. So, the maximum effective pass pressure is called the pre-consolidation pressure. So, this is very, very important. So, if you want to construct some building or any structure on the soil, you need to know what is the pre-consolidation pressure of that particular deposit. Now, why you need to know? You need to know that pre-consolidation because you need to find out at which pressure the soil was already compressed. That is a pass pressure, the soil was already compressed and soil has experienced that much of pressure. Now, whatever pressure I am applying due to construction of some new structure, whether that is giving more than that past pressure or less than that past pressure. That past pressure is very, very important for me. If it is, if my structure is giving pressure which is more than the past pressure, then I will be observing or I will be expecting some different behavior. Whereas, if my past pressure is greater than the new existing or new applied pressure, then my behavior will be different or the soil behavior will be different, right. So, this is very, very important. So, for that Casagrande in 1936 suggested some graphical construction to determine pre-consolidation pressure sigma C prime. So, let us see how we can find out. Okay. So, Casagrande has proposed this is some E log sigma prime plot, okay, and this is the plot. So, we will explain all those things, what are the steps are involved to find out the pre-consolidation pressure. Now, this is the figure, whatever figure I just showed you, I have taken that thing in a smaller scale to understand this thing. The first thing is that first step by visual observation establish a point A, okay. By visual observation establish a point A at which the E log sigma prime plot has a minimum radius of curvature. So, that comes from visual observation, and because of the visual observation it is dependent on individual's perception, right. Anyway, so you find out the point where the radius of curvature is minimum in the E log sigma prime plot. So, that is nothing but a point A. Now, in the next step, draw a horizontal line AB, okay. Draw a horizontal line AB. Then in the third step, draw the line AC tangent at A. So, AC. So, that is nothing but the tangent at A. So, you draw a line AC which is tangent at A. Draw the line AD which is the bisector of the angle BAC. So, AD which is nothing but the bisector of angle BAC. Okay. Then project the straight line portion GH. So, what is your GH? This is your GH, right. This is the straight line portion, of course. Project the straight line portion GH of the E log sigma prime plot back to intersect AD, okay, at F. Okay. The abscissa of point F is the pre-consolidation pressure sigma C prime. Understood? So, we have got the pre-consolidation pressure. So, what does it mean? If your pressure, if your applied pressure is less than sigma C prime, the behavior of soil will be different, because the soil will be behaving as over consolidated soil, and if you cross this limit and if you move in this direction, that means your applied pressure is greater than your sigma c prime, then the behavior of soil will be different, that will be behaving as normally consolidated soil. I hope that you have understood. So, the steps involved. So, this is proposed by Casagrande, right. So, these steps if you follow, then you will be getting the pre-consolidation pressure sigma c prime, and that will give you the boundary, okay, which will tell, okay, if you are on the left side of the boundary, then the behavior will be something else, and if you are on the right side of the boundary, then you will be having some different behavior. Now, based on that, we can find out that how much over consolidation or how much over consolidated soil we are having. The over consolidation ratio is is indicated or is applied to find out that thing. So, the over consolidated ratio for a soil can be defined as OCR is equal to sigma c prime by sigma prime, okay, where sigma c prime is nothing but the pre-consolidation pressure, whatever just now we have seen, and sigma prime is the present effective vertical pressure, right. So, if your OCR is 1, if your OCR is sigma c prime is constant, right. So, sigma c for a particular soil or for a particular deposit, sigma c prime you have obtained. Now, is this sigma prime you can play with, because now you are going to apply some extra or additional pressure or some external structure you are putting. So, because of that you are getting some sigma prime. Now, you can vary sigma prime, but sigma c prime is fixed for that particular deposit. Now, so once you increase sigma prime gradually, right. So, initially sigma prime will be maybe less than sigma c prime or maybe greater than sigma c prime. If it is less than sigma c prime, then your OCR will be greater than 1. So, if your OCR is greater than 1, that means the soil will be behaving as over consolidated soil. Am I right? If your OCR is becoming less than 1, that means your soil will be behaving as normally consolidated soil. Your OCR 1 means you are at the boundary, that means if you just cross the boundary, you will be entering the normally consolidated soil range or the region, whereas just on the left side you will be entering the over consolidation range or the region. So, I will stop here today. So, in the next lecture we will see that we will try to find out how to observe the or how to calculate the deformation or the settlement due to consolidation from 1D consolidation theory. Thank you very much.